Meet Lisa. She wants to know everything about hydrocarbons. So let's sit and talk her first of all, what is UPAC? The UPAC is the International Union of Pure and Applied Chemistry. The UPAC strives to advance chemistry in part by setting global standards for names, symbols, and units. It is important to have defined rules to name hydrocarbons because in that way everybody will know how to do it, no matter where they are from. Have you heard about natural gases and fuels, or plastics or paraffin? Well, all of those are the most common hydrocarbons, so stay and learn how to name them.
A hydrocarbon is any of a class of organic chemical compounds composed only of the elements carbon and hydrogen. The carbon atoms join together to form the framework of a compound, and the hydrogen atoms attach to them in many different configurations. The classification of the hydrocarbons depends on the type of bonds involved in the structure. Alkanes are described as saturated hydrocarbons, while alkenes, alkynes, and aromatic hydrocarbons are said to be unsaturated.
An alkane is a hydrocarbon that only contains carbon and hydrogen. It contains single bonds, as shown in the image. It also has 4 bonds to every carbon atom, and they are also non-polar. How do we name alkanes? First, we name the main chain, that is the longest continuous chain of carbons in the molecule. Then, we number the carbon atoms in the main chain. Next, we identify and number the branching substituent. Finally, use hyphens to separate the different prefixes and commas to separate numbers when they are more than one. List them in alphabetical order. If one or more identical substituent groups are present, use one of the Greek prefixes. As you can see in the image, here is an example of some alkenes following the steps that we already mentioned.
The alkenes are hydrocarbons which respectively have carbon-carbon double bond and are unsaturated hydrocarbons. The UPAC rules for alkene nomenclature are: first, the "-ine" suffix ending indicates an alkene. Second, the longest chain chosen for the root name must include both carbon atoms of the double bond. Third, the root chain must be numbered from the end nearest a double bond carbon atom. Fourth, the smaller of the two numbers designating the carbon atoms of the double bond is used as a double bond locator. Fifth, in cycloalkenes, the double bond carbons are assigned ring locations first and second. Substituent groups containing double bonds are vinyl group and allyl group. Alkynes are organic molecules made of the functional group carbon-carbon triple bonds and are written in the empirical formula of CnH2 times n-2. The first rule for naming the alkynes by the UPAC is: find the longest carbon chain that includes both carbons of the triple bond. Second, number the longest chain starting at the end closest of the triple bond. Third, after numbering the longest chain with the lowest number assigned to the alkyne, label each of the substitutions and its corresponding carbon. If there is an alcohol present in the molecule number, the longest chain starting at the end closest to it. Fourth, substitutions containing a triple bond are called alkyne. For example, 1-chloro, 1-ethynyl, and 4-bromocyclohexane. Fifth, a molecule that contains both double and triple bonds is called an alkyne.
For UPAC, nomenclature of aromatic compounds, the substituent is placed as prefix to the word benzene. Many substitute benzene compounds are popular by their common names. For example, methylbenzene, methoxybenzene, aminobenzene, etc. If a benzene ring is distributed, for example, contains two substituents, the position of the substituents is defined by numbering the carbon atoms in such a way that the substituents are located at the lowest number possible. In the trivial system of nomenclature, the terms ortho, meta, and para are used as prefixes to indicate the relative position of the substituents present. Ortho is used to indicate that the relative position between the substituent is present, is 1, 2. O can alternatively be used in place of ortho. For example, ortho-dibromobenzene equals O-dibromobenzene. In some cases, common name of benzene derivatives is taken as the base compound. Substituent of the base compound is assigned number 1, and then the numbering is done in such a way that the next substituent gets the lowest number. When a benzene ring is attached to a side chain which contains a functional group, the benzene ring is considered a substituent. The name of benzene as a substituent is phenyl.
I really like this topic for the hydrocarbons because I really think that it is a very interesting topic. I really want to know more of it because I have a lot of doubts and curiosity of most of all, because thanks to hydrocarbons we have a lot of materials we use in our daily life, like plastics and all of that stuff, like using the car and the light, etc.
In this project, I realized the importance of the hydrocarbons in our life because we use them almost in all the things like plastic, in natural gases, and also in fuels like petroleum. But they are harmful because they contribute to the contamination in our planet. So we have to take care and control the use of the hydrocarbons.
I think that this topic is very important considering how complex organic compounds can be, along with organic chemistry that serves a lot of purposes, being fuel and other types of energy sources, the most important one.
I really enjoyed doing this project because it was very helpful for me to completely understand the topic that we mentioned. And also, I learned about the hydrocarbons and how they are everywhere and they are very important in our lives, but they are not also the best for our planet. And I think that we need to take care of our planet and to take care of the use that we give to the hydrocarbons so we can reduce the contamination or whatever that the hydrocarbons are doing to our planet.
Our team conclusion is that the hydrocarbons are a really interesting topic and we'll want to know more of everything of them. We'll want to know if there is a way that these compounds can help to our planet by stopping the contamination so we can still using them without damaging ourselves, because most of these materials are damaging the atmosphere and release the global warming.